our moon's near and far side are very different and a gigantic ancient impact may be to blame. Scientists are confident that this provides a reliable explanation to one of the biggest mysteries of the moon. The visible side of the moon is very different in its relief from the half that is not visible from the Earth. The near side is dominated by seas, dark, vast, and relatively flat areas formed by ancient lava flows. The far side is cratered and lacks regional sea-like landforms. Scientists first learned about this difference in the 1960s, when automatic stations, and then manned spacecraft, flew around the moon and took pictures of it from all sides. Further studies, carried out from orbit, established that the surface of the moon is also heterogeneous in its chemical composition. On the visible side of the satellite, in and around the ocean of storms, is the creep anomaly with high concentrations of potassium, K, rare earth elements, REE, and phosphorus, P. Fuel elements such as thorium have also been found in the area. In other regions of the moon, these substances are rare. It is assumed that the elements of creep should be concentrated in the layer of the moon's mantle that solidified last, i.e. they are evenly distributed directly under the lunar crust. Some scientists have suggested that the chemical anomaly in the ocean of storms is associated with lava flows, but there was no explanation for why these elements are concentrated on the visible side of the moon. A new study by scientists from multiple universities tried to answer this question. On the southern part of the far side of the moon is the large South Pole Aitken Impact Basin, which was the target of China's Change 4 mission in 2018. This is the largest impact formation on the moon. Its dimensions are 2,400 times 2,050 kilometers, and the maximum height difference between the shaft and the bottom is 16 kilometers. It is believed that the crater was formed as a result of a collision of the moon with a protoplanet that occurred at the dawn of the solar system. American planetary scientists have investigated a possible connection between the formation of this basin and the creep anomaly on the visible side of the moon. To this end, scientists carried out a computer simulation of heat flows propagating through the bowels of the moon after the impact of a large meteorite. The movement of rare elements in the lunar interior is a result of a massive impact. According to the simulation results, the creep elements were displaced along the surface of a heat wave propagating through the interior of the moon. The team ran simulations of various impact scenarios in terms of force and direction, but in all cases, despite different thermal characteristics, rare earth elements and potassium were carried out to the visible side of the moon on the crest of the emerging heat wave. The results were in full agreement with the chemical anomaly in the ocean of storms.